Hello and welcome to the Deep Sea Podcast, a punk take on a science podcast about everything deep sea. I'm Dr. Thomas Linley, and with me is the Professor, Alan Jamieson. Hello, mate.
Hello.
You're coping with the heat for the sake of sound quality.
I am.
And we salute you, sir. We salute you.
I know. At least I'm not in a cupboard anymore. I'm actually in an office, but I've had to switch the aircon off because you complain.
I said I could do it. We could do it in post.
No, I know, but you'll say that now until you have to do it, and then you'll be like, oh, you had your aircon on. It'll be like James Cameron clicking his pen all over again.
You'd think he'd know.
I know.
Maybe it was all just a power play. Maybe he knew it'd mess with us.
For a guy who spends his days on a film set, you'd think you'd know to stop clicking a pen.
Or he's like, oh no, what if it was code? What if he was asking for help and we've just ignored him?
Oh, yeah, maybe that's it. I'm here under duress. Yeah. Send help.
They won't let me stop making the film. I'm so tired. I want to make a different film.
Yeah, we should have that analysed for Morse code.
Okay. It might be revealed. Or he's just being horrible to us. These two idiots somehow dragged me on here.
Yeah, somebody kill me.
His film's doing all right.
Is it?
Overtaken his last film.
What film's that?
Avatar 2, The Way of Water,
oh,
has overtaken Titanic as the highest grossing film of all time.
Isn't that because there's more people in the world than there is back then? Is the percent still the same? Let's be scientific about this, because people say they outsell the Beatles, but the population of the UK has doubled since the Beatles, so if it could be a percentage thing.
Oh, we'll have to look at the stats.
Yeah.
We'll have to model it. But, I mean, it's past Avengers, which falls in between.
Oh, really? Oh, there you go. It must be a good film then.
Yeah.
Have you seen it?
No.
Nor have I.
I really want to. I haven't been to the cinema in over 3 years, and that sort of correlates with the appearance of a small person that needs constant monitoring. So I haven't actually seen a film in the cinema since he arrived.
I heard it was more than 25 minutes long, so there's no way I can stay awake in a cinema for that film. So it's me out.
You live at such a permanent state of exhaustion that as soon as you're in a dark room,
yeah, pretty much put the lights off, both out.
Like a parrot. Just put a cloth over your cage and you're out.
The 25 minutes is the time it takes to eat the popcorn. And once the jaws stopped crunching, it's just like there's nothing else to do, so just poof, out.
Standby mode.
Yeah. I
can remember both of my parents falling asleep in Space Jam and then feeling like, oh, I'm a bit unsupervised.
Oh, you should have liked it.
I know, it did cross my mind. It's just like, I can enjoy the film. Also, I'm unsupervised.
Or you could have just moved to the seat behind them and then watched their faces when they wake up and realise you're not there.
No.
And sit there with your popcorn saying, this is better than the film.
How you doing? What's going on?
Lots going on. Advertising lots of jobs to come and work for me.
Right.
If anybody wants a job, just give us a call. I'll give you a job.
Careful what you say.
There's heaps of jobs going. No, there's
buckets of jobs.
Buckets of jobs. I think we're advertising about 9 at the moment. Maybe some more coming.
Right.
I don't know. Big expansion.
Are they all up on one page? Because we will put them in the show notes. We do have a lot of people who listen, and plenty of people who get in touch.
Yeah, there's 3 deep sea biology postdocs on the go, and there's a couple of deep sea data analysts, a senior research officer, and so on and so on. So we're just looking for good people. We're not looking for people who are particular skill, because we've basically got the ship for the next 5 years in the sub. We can go do whatever we want to do. So we're looking for people who can look into the types of stuff we do and look at the limitations of what we can and can't achieve and think about how they can contribute to that and enhance it.
Sounds like a fantastic opportunity. Go on, listeners. There's jobs to be had. A lot of people email how to get into deep sea. Well, this is probably it.
So the best way to get into deep sea is jump off a ship.
Is that our new T-shirt?
Yeah.
Or is that going to be the stock answer when somebody quite honestly asks us nicely for career advice, and we just tell them to jump in?
Yeah, pick up a section of railway line and jump off the ship. You'll be in the deep sea in no time.
We could probably calculate how quickly you'll be in the deep sea.
I reckon 50 metres a minute. Half an hour.
That's a good. It seems to be like terminal velocity, doesn't it?
Half an hour, 1,000 metres is normally the thing, isn't it? So it depends. It depends. We can argue about when the deep sea starts again. Real deep sea was going to take half an hour.
Proper deep sea,
yeah.
Not this poser deep sea.
Yeah.
Proper deep sea.
Yeah.
Good stuff. And you had a song of the month that you alluded to.
Yeah.
That has a story.
Yeah, it's a song of the month, and it's dedicated to a woman I never met. So I was sent a photograph of a young Canadian woman wearing a Deep Sea Podcast hoodie.
Oh, yay.
And it was sent to me by none other than our mate Shane. Remember the guy I tattooed?
Yes.
His good lady is called Michelle, and she's a big fan of the show. So I'm trying to think of songs with Michelle in the title. I can only think of Guns N' Roses' My Michelle. So it's a dedication to all of the Michelles, but particularly that Michelle, because you're a legend, and you let me tattoo your husband. And apparently it was her idea. So that's what I heard.
And has forgiven you.
Yeah, she not only should have forgiven us, she bought a hoodie. So she's given us like $2 or however much we charge for these things.
I don't know, I measure it all in pints now. It's actually an easier exchange rate than working out Aussie dollars and UK pounds. All the company accounts are in pints now.
But if you're referring to currency in pints, shouldn't we just come up with a new one like Pinto?
I know, cryptocurrency, Pinto.
Yeah, so the hoodies are probably about 4 Pintos.
It's quite catchy. Cool. Some newsy bits then. What's been going on?
Are we calling this section Newsy Bits now?
Well, I always try and avoid saying deep sea news because there's quite a famous blog called that, so I didn't want to tread on that too much.
All right, Newsy Bits it is. Newsy Bits is fine.
Newsy bits brackets deep sea edition.
Yeah.
So actually, the first one is you.
Oh,
you've got some new records.
Yeah, I wrote a paper with the guys from Japan. We had a few significant depth extensions of various fauna, which we thought were quite interesting. So we put a short note in just to get them on the record. And first one is the deepest jellyfish of all time. It's the first time we've seen a jellyfish deeper than 6,000 meters. And that was on the dive that I interviewed Tim McDonald for this very podcast. That interview, I think, was just after we saw the deepest jellyfish in the world. The other one was those predatory tunicates, the like big transparent zippy mouths, if anyone in Britain remembers the TV show Rainbow. So like a big gummy mouth that stick to rocks. We saw one of them a couple of months ago in Japan at over 8,000 meters. The previous deep one we saw a couple of years ago in the Mariana. So I think that's another several thousand meter depth extension. And the last one was ctenophores, or comb jellies. There was a comb jelly around 10,000 meters in Kermadec. And in Japan, we saw the benthic ctenophores at around 8,000 meters. So they're
like stalked, aren't they? They sort of stick and then have their tentacles.
No, there are two sort of tendrils that come down, but the benthic ctenophores actually join on the other end. So the tendrils actually sort of flow away from the bit that's attached.
Oh, okay.
You can see that Dougal does the morphological description of these things. The big blobby bit at the end that sticks to the rock is, I don't know, its head, and the rest of it sort of flails behind it in the current. So it's just very simple. I like those simple papers.
Well, it is what it is.
Well, the point is when you get down deep, density is obviously not necessarily low, but it's low relative to how much you can see and how much you can sample on a given day. So these rare observations are actually quite useful. And after you've done so many landed deployments, so many sub-deployments, it's nice to sort of pull all these singletons, we call them, or rarities, and put them together. And then when you start looking at, my God, these things are actually getting down to 10,000 meters, you think, well, the biogeography of these things is likely huge. It's just that you don't come across them very often. It's not because they're rare, it's because they don't necessarily appear in something when you've only got a field of view of a few meters. So it comes with time. And we're just trying to get them on the record just to show that most major marine taxa are present down to very deep depths. And these ones weren't logged before.
We've been quite limited by our gear as well. We've not had equipment that sort of allows the survey of these groups. These aren't easily seen.
Yeah, for some of those, the ideal way to do it would be put a long-term lander or mooring down with a camera almost continuously recording or triggered by motion sensor or something like that. But nobody has that kind of money kicking around. And, in an ideal world, you would put 10 in every trench and then just watch things drift by the camera. But unfortunately, the logistics and reality of doing that is very hard. So I was quite chuffed with that little paper. I thought it was quite cool.
Nice one. That'll be in the show notes. See some new records. And not just little bumps in the numbers, like multiple thousands of meters deeper than we've seen them before. Another one I spotted was the latitudinal gradient of deep sea invasions by marine fishes, which is a nice way of saying something we've talked about before, how a lot of deep sea colonization seems to happen in the poles. So by being cold adapted, you seem to find it a little bit easier to go deep. And that seems to be where we get a lot of our deep sea fauna is at the poles. And it's true for the fishes and the vertebrates and the invertebrates as well. So this is a physiological thing, probably. You're good at being cold. That means you're good at being deep as well. Or it's easier to go deep.
So that means Norwegian people can swim deeper than people from Hawaii?
Yes.
Great.
Absolutely.
Kind of clarified that then.
Although that contradicts the like Mediterranean warm all the way down, allowing shallow species to go deeper.
I know, that's what I'm trying to say. I thought the whole point was if you were warm, you can go deeper.
I think one is sort of evolutionary and one is physiological. So I think warm all the way down makes it easier for things that aren't adapted to go deeper. Whereas if you have evolved in a cold place and adapted to that, you are able to go deeper easier. But it's you that's different, not the environment. Whereas when in warm spots, shallow animals seem to go deeper, that's the environment that's allowing that.
What you're saying is a Norwegian fella can swim deeper in Hawaii than a Hawaiian fella can swim in Norway.
That feels like it works. That works as an analogy.
Yeah.
Norwegian guy's having a lovely time.
Yeah, he's having a great holiday, whereas Hawaiian guy's dead with hypothermia.
Yeah, it's not an hippy dipper. Not super deep sea, but I know we enjoyed our little adventure into caves. There has been a new fish species discovered living in an Indian aquifer, which is a very cool looking thing. So researchers conducted a 6-year study of water-bearing laterite rock layers. So tiny little cracks and fissulas in these rocks. And they have fish fauna, the stuff living in there. So in the southern Indian state of Kerala, there is a catfish genus, which is sort of totally dedicated to this weird lifestyle. Oranglanis, I think. And they live exclusively in aquifers. They're very small, they're blind, and they lack pigment, but they are a sort of shocking, sort of fleshy, bloody red color. So it's probably a low oxygen environment. They're probably doing a lot of gas exchange over their bodies as well, because there might not be room to ventilate your gills. So they only come to the surface really when a domestic well is being dug or cleaned. And so the team actually relied heavily on citizen science to collect data. So they just let people know, you're digging a well, you see one of these weird things, we want to know about it. And the study found a new species. So it's only 32 millimeters long, no eyes, blood red body, and genetically distinct from the others known. And it's a lovely sort of citizen science story as well as an interesting fish, because they would not have gotten this data without engaging the community, which is nice. You had a new story of the phantom jelly.
Yeah, no, this is cool. Multiple layered. So this is a new paper that's come out from scientists who are employed by Viking expeditions or Viking cruise liners. And a lot of these cruise liners have submersibles now. And we've been recently talking to a company about maybe putting these things to good use, that if there are people going to exotic places and diving in submarines, could they just leave a camera on, and over time, it's not quite citizen science, it's almost the other way around, where they collect data and give it to us and have a look at it. But anyway, so it turns out they're already doing this on Viking, which is great. And they did a whole bunch of stuff around Antarctic Peninsula down to 280 meters, and they got a whole bunch of images of the giant phantom jelly, which is a scyphozoan known as Stygomedusa gigantea, which is the really cool looking thing. It's very ribbony, very long, very big.
I think when we talked about it before, I said it looked like a lovely duvet, and like you could sort of cuddle up in it.
Yeah, it's a big long thing, but the thing that I thought was interesting, that it has a symbiotic relationship with a ophidiform fish. You heard of this?
No.
Thalassobathia pelagica. Apparently it lives in the umbrella of the phantom jelly, and if they're separated, they will actually reassociate with one another if they come across each other again.
Like on an individual basis, they recognize each other.
Yeah, apparently they forged some sort of weird friendship. But the thing I thought was cool was, like, what did they get out of it? So the gigantea provides food and shelter for the fish, and the fish aids the giant phantom jelly by removing parasites.
Yeah, that is very cool.
Parasites, Tom.
Parasites on jellies?
Yes.
I didn't know.
Deep sea parasites, although it's not that deep sea, but it's a little bit deep sea.
Yeah, that's good. Well, that sort of leads us on to today's topic. We were covering sort of habitats, and this has been one that's been requested for a long time. So what if the habitat is another organism? And we've touched upon symbiosis a few times, and I think in colloquial sort of language, we use symbiosis sort of incorrectly. We usually use it in the sort of nice commensal way, but symbiosis basically just means living together, or together living from the original Greek. So it's any type of close long-term biological interaction between two different organisms, and they need to be different species basically. So in 1879, Hendrik Anton de Bary defined it as the living together of unlike organisms. And symbiosis can be obligatory, so that means that they have to live together. These animals won't survive independently, or these organisms, sorry, it does exist in plants, won't survive independently. Or it can be facultative, which is sort of optional. And we saw this with the hydrothermal vent communities. You know, there's the worms that have the bacteria actually within themselves in a specialized organ, and it's mutually beneficial. Then there's sort of the bacterial farmers who sort of graze and eat the bacteria and just sort of encourage its growth. So there's lots of different ways that symbiosis comes together. It's not necessarily always beneficial for both parties. And there's loads of different ways of defining it. I think there's sort of 5 broad groups. So one that we often call symbiosis is when sort of two species both benefit from the relationship, and that's called mutualism. If one of them benefits and one of them isn't affected at all, so, you know, something tiny living on something absolutely huge, it doesn't even notice, that's called commensalism. If there's no effect to either of them, that's called neutralism. If one is benefiting but the other one is being harmed, that's parasitism, which we're going to talk about today. If one has no effect and the other one is harmed, this was a new one on me, and I had to look at some examples because I couldn't think of any off the top of my head. Amensalism. So an example they gave of that was a huge tree with a little sapling in its shadow trying to grow. The sapling's got no effect on the big tree at all. It doesn't care. But the big tree is sort of removing light and resources from the little tree. So that was an example of that. And then if it's negative on both counts, that is competition. So maybe competition for resources. So yeah, I thought it was interesting that we sort of use symbiosis only in its fluffy, nice, everyone benefits form. But actually it just means very close association of organisms.
That was very interesting, Thom. I learnt a lot there.
So which leads us on to parasites, to another organism as a habitat type in the deep sea. Who should we talk to about that? It's actually somebody who's come up. I think we maybe even teased this, and I was really glad he was up for having a chat with us.
Yeah, no, this is a guy that I think his last cruise was the first one I ever did, way back in the day. So I didn't realise at the time that I was actually sailing with a lot of the big names. And there was a guy there called Rod Bray, National History Museum, and he was picking parasites out of various deep sea fish and withdrawals. And at the time I was a mechanical engineer and I couldn't really care less about that room. All the smelly stuff came in, so I didn't really have much to do with them, to be honest. But I remember him pulling all sorts of weird stuff out of this, that and the other, and I thought, oh, that's really interesting. But I'd never really had the guts to go and ask him what he was doing. And so he was the only parasitologist I've ever come across. And it turns out he's very much still in the game.
I like the mental image of him in the back with all the messy stuff when you didn't really care about it. And it's a bit like a magic trick, when they keep pulling the silk hankies out their sleeve.
Yeah.
It's that, but it's just a fish's guts and this enormous worm.
Isn't that what you're supposed to do? You're not supposed to roll the tapeworms around a pencil very gently.
Oh.
Yeah.
Is that tapeworm or is that the ones that bore into your body?
I can't remember. I don't want to think about it. But yeah.
Oh.
Anyway, Thom gave him a call.
I'm joined by Dr. Rod Bray, a parasitologist specialising in the systematics, phylogeny and biology of parasitic worms, particularly the flukes. His work on deep-sea parasites remains influential in the field since his retirement from the Natural History Museum in 2004, where he worked as a scientific associate since 1967. And I know you're still a regular visitor to the Natural History Museum because that's how I managed to get James to track you down. You can't seem to stop scientists and get them to retire properly. That seems to be actually when they get most of the work done.
Well, yeah, I think we've been pretty active since I retired in 2004. And in fact, I'm doing field work next week down in Australia, so I'm still active.
Wow, you're getting that far away.
Yes. When I retired, I more or less gave up on cruising. I did a couple of cruises after I retired, but then I had a long association with University of Queensland, so I've been working within the South Pacific on the fish parasites there. And for some reason or other, I thought that might suit me better in retirement than cruising in the North Atlantic.
Yeah, the slightly more comfortable conditions.
But I did a couple of cruises after I retired with Monty Pried.
Yes.
You know Monty, presumably?
Yeah, he was my sort of mentor.
Yeah.
I worked with him in Ocean Lab for a while. His deep sea fish book is forever open on my desk.
Yes, I can imagine. Yes, he was very, very helpful, and because obviously I couldn't afford from the museum to run cruises like that myself, so I was very fortunate to get on quite a few of Monty's cruises.
I think Alan, his very first cruise was with you in the Atlantic with Monty, probably one of the old Discovery ones.
Yes, I think it was. And if I remember rightly, we had to put him off in Cork Harbour with a dental problem.
Oh, it's the tooth one. Yeah. His face swelled up.
Yeah. No, I think that was the only time I sailed with that Alan Jamieson. My first cruises were on the Cirillana out of Lowestoft, looking at the possibility of deep-sea commercial fishing in the early 70s with a chap called Alan Jamieson.
I didn't know there was another one.
Oh, yes, there was one. He started early on sort of electrophoretic stuff, eels particularly. But then we went out and collected some things like microids and looking to see whether it was possible for them to use that as commercial fishery. Didn't work out, their recruitment was so slow and that sort of thing that it sustained a fishery.
Yeah, and they're not that tasty even after all that.
No, I don't think so. No, did try one or two and I'm very keen, I must say. But no, that was interesting because we started looking at macroids, which was starting to think, you're getting deep sea parasites out of that sort of thing. And some of the chimeras and things like that, we got some interesting stuff out of. But that was working sort of on the upper shelf, really. They're down to about 1,000, 1,500 meters, down the slope rather. So it was interesting, and I was learning what I was doing and making all my mistakes in one go. I hope. But, finding ways of collecting things. Because the problem with looking at parasites is you have to get a host and then you have to open it up and look inside it. And you need to really do that fairly rapidly after you've collected the stuff. Otherwise, it gets very horrible.
Yeah, it's a race against time with anything deep sea. They break down so quickly. Yeah. That atmospheric pressure and atmospheric temperature, things just melt in your hands.
That's right.
I can remember touching a cusk eel and it feeling fizzy. So it's breaking down in front of you. But the stuff in the body cavity isn't too bad. I've certainly opened up macrurids and cusk eels and just been greeted with a mass of worms. But things that are actually within the tissue, I can imagine that's a lot trickier within the sort of muscle mass.
Yeah, it is. I mean, also, you can get decent specimens if you do it fairly rapidly. But, I mean, you obviously lose some. If it's coming up through a great depth, you get this stomach extruded through the mouth. So you lose all the stomach parasites, probably. You can't really tell. And then sometimes you get the rectum pushed out, and you lose rectal parasites. So most of the material that I collected was intestinal parasites. So you catch most of those okay, I think. You just have to get down and do it. What I used to do is to collect good samples in the first, say, 4 hours, and then freeze a lot of stuff. It's pretty grotty, but you can count things, that sort of thing.
Yeah, it's such a rush when a cruise comes in.
Yeah, that's right. But, that's part of the exercise, and you get used to it.
If it was easy, everyone would do it.
That's right. Well, it did turn out, actually, that when I worked with Monty and in the abyssal plain, mainly down on the porcupine abyssal plain, that this is the only time any sort of parasitology has been done in the abyss, as far as I know. Not seen anything that really goes that deep elsewhere in the literature. There's not much literature anyway.
Not that's been systematically looked at.
No.
We find something particularly interesting, we'll put it in a jar. But I think from what you've said already, you need to be dedicated to it. You need to be actively looking for parasites. And deep sea samples are so rare. Everyone's fighting over them.
You do, really. I mean, yes, a lot of the ones that you're looking for, they're quite small, a lot of them, and you need to know what you're looking for, really. You get used to it but after a time, but it means that it's fairly labour-intensive, but it's rewarding in that you're finding something that really nobody's seen before. So it's worth doing. I would encourage people to look further into the parasites. There's so much to be done, so many areas in the world that haven't been explored at all. Young folk, I know, just starting to think about doing this sort of thing with modern techniques, particularly molecular techniques.
And that's what we're hoping to encourage on this, basically. We've had a lot of listeners ask about parasitism, and I know a lot of our listeners are sort of undergrads, so we're hoping to seduce some people into parasitology. It's a very open area right now. There's lots of research to be done. Now,
I mean, there are ways of getting at things like the hydrothermal vent stuff. People are now starting to look at that area, and that's really fascinating. It looks as though there's a completely different fauna there, parasites as well as everything else. But we have managed to get a bit of molecular phylogeny done on some of our worms, and they are, as it looks to be, a unique radiation around that sort of area. So that, there's really interesting stuff to be done in there. And because of the life cycle, how that works down there, a fascinating and completely open area really at the moment.
Yeah, that's certainly an area I want to get into because there's some unique difficulties to the deep sea relative to shallower parasitism.
Well, that's right. But now you can tie up a life cycle with molecular means that you can actually do some proper life cycle studies. Because before it was very difficult. You pick out a nice worm from an intermediate host and say, well, it looks like that, or it could be something like that. But they do change their morphology quite considerably during development and metamorphosis. So quite often the larval stages or the early stages are really not identifiable with adults in morphology.
Lots of multiple species that turn out to be one.
Yeah, we're finding that. I must have to admit, we've not done really population dynamics works on deep sea stuff. But I finished collecting in the early 2000s, and sequencing wasn't that easy or cheap in those days. But now, we've been doing stuff on the reef fauna where we find there's an enormous complication in the actual population genetics of particularly Digenean parasites. But that'll be the same wherever you look.
Yeah, you just find more and more. What are the sort of main groups of parasites we find in the deep sea?
Well, the ones I'm looking at are Digeneans, that's trematodes, that's flatworm group, very common in marine environment. Within the group of flatworms, there are 3 major parasitic groups. That's the tapeworms, cestodes, and the ectoparasitic flukes, the monogenians. Neither monogenians or tapeworms are that common in deep-sea teleosts. Cestodes are very common in elasmobranchs in the deep sea and everywhere else. And monogenians seem to die out towards the deeper waters. These have a direct life cycle, so you have to have contact between hosts for it to pass on. Whether there's not enough close contact between hosts, organisms, to sustain the life cycle might be the reason why there are fewer monogenians.
There isn't really a swimming stage. They've got to actually bump up against each other.
No, not a free, not a, because the didinians, they have a much more complicated life cycle. They have usually 3 hosts and go into a mollusk, often a snail or a bivalve, as the first intermediate host. In that host, they reproduce parthenogenetically. Organisms at that stage are called parthenidae, and then they produce enormous numbers of offspring called cercari, which they come out of the first intermediate host and in various ways get taken up or swallowed or burrow into the skin of the second intermediate host, which can be almost anything: crustaceans, annelids, a lot of them echinoderms, small fishes and things like that. And then the final host gets the parasite by feeding on the intermediate hosts, and that's where the adult worm matures. Then virtually all hermaphrodites, and then they produce eggs, having usually been fertilized. We think sometimes self-fertilization, but usually, as far as we know, they tend to crossbreed between individuals. So the Degenian life cycle is complicated, but it does give, because of the enormous numbers of cercaria produced and the enormous number of eggs produced, they do seem to be able to sustain a deep-sea life cycle much better than some of the other groups.
They hedge their bets.
Hedging their bets, yes. I mean, it's like most marine things. They produce enormous numbers of offspring, and a very tiny percentage actually survive.
It's just interesting that there's sort of 2 reproductive phases to the life cycle. There's the mollusk phase, which is just using it as a bit of a factory.
Yeah.
And then there's that intermediate stage where it's sort of predator-prey relationship. So they're reproducing in the mollusk and in the final host.
That's right. It's a way of producing enormous lot of offspring so that you do sustain a population. You know, sometimes when you think about it rationally, it's quite amazing that it can survive.
Yeah.
But, they're the group I've worked on most, so I might be a little bit biased, but they seem to me the most ones you find of flatworm parasites anyway. Of course, there's lots of nematodes in these things, which I haven't really explored. And then there's things like the ectoparasites, the copepods particularly, are pretty common down in the deep sea. You'll probably come across some of them on macroids. You have these sort of black welts on the surface of the head of the macroids. You can see that that's a sac produced by a parasitic copepod, and it's full of a sort of black inky stuff if you burst them open.
I didn't know that's what those were. Yeah.
I've collected a few of them. There's quite a few copepod parasites. Then you're getting into things that I know virtually little things about, like all the apicomplexans, what we used to call protists, myxozoans, and then, of course, viruses and bacteria. And, everything's got some fairly large number of parasites in. A lot of them are completely unknown or can only be deciphered by molecules nowadays.
Yeah, we've hardly touched on sort of bacteria and viruses.
Yeah, that's right. My view of what I understand about deep sea parasitology comes to a great extent from Digenians, and it does emphasize the fact that we know so very little, and a lot of what we presume about what's going on down there is related to what we know happens in shallow waters to the same sort of groups of parasites. So we presume the same sort of thing is going on in the deep, but in most cases we have no direct evidence of that.
There's a lot of extrapolation, but it's all we've got to work on.
Well, that really is at the moment, although, as I say, there are some work being done in the States now. People are actually finding hydrothermal vent stuff, having got several of the life cycle stages sorted out. This is a very exciting area that is possible to do now. One thing I didn't do when I was working was to collect the intermediate hosts. That would be a viable idea now, is to do a lot more work in collecting deep-sea mollusks, deep-sea annelids, that sort of thing, and having a good look through them and see what you can find. That would be a very useful and interesting thing to do, along with collecting the adult worms. And now, as I say, you can really complete life cycles and start really sorting out some of the fascinating complications of the life cycles of these groups.
When you mentioned about extrapolating from shallower groups, some of your work found a sort of link between polar and cold adapted species sort of relating down to bathyal depths. It's something we see a lot, in becoming cold adapted seems to give you a bit of a leg up to being deep adapted.
Yes, yeah, that's definitely what appears to be the case. Certainly the deep sea fauna does seem to be very closely related, particularly to the Arctic and the Antarctic. But there's been quite a bit of work done on the Antarctic stuff. And the parasites are very similar, possibly not the same species, but sort of have quite a few genera in common. I mean, we've done a bit of work has been done on the molecular phylogeny, and we're pretty happy that they are pretty closely related. Yeah, it does seem to be cold adapting is very important to where you are in the deep sea. And also, I mean, there has been quite a long tradition of this thing called equatorial submergence. I don't know whether you get that in fishes but with the parasites, a lot of the things that have been known from the higher latitudes seem to be found in the deep sea and, in equatorial regions. This is sort of just an idea that had been floated for years, and it does seem to have some basis.
The thought I had is that, when it comes to colonizing the deep sea as a parasite, of course, you can join your host. You're almost taken down there. So as the deep was colonized after one of these mass anoxic events, as the host evolves and recolonizes the deep sea, I guess it brings its parasites along with it, and they've got to either adapt or bust, basically.
Yeah, that's right. No, it does look as if that is the case. We don't know how much actual life cycle is going on in the abyss, whether most of the stuff that we're finding has been taken down there by fish as they get deeper. I mean, this Coryphaenoides armatus is the really common thing that we've looked at down in the water, and that has quite a depth profile. So it probably picks up parasites, and the life cycle is probably mainly of the parasites is in the slightly shallower waters than the abyss anyway. But we don't know, again. But it does seem that there's quite a lot of invertebrates in the abyss that could be intermediate hosts. I don't think there's any shortage of candidates down there. And it does seem to be there's some sort of relationship between parasites and the fish going down within their actual individual life cycles into deep water.
Yeah, of course. They've got shallower stages as juveniles, so they could always pick them up as juveniles and then take them with them. They're in the plankton, actually, as juveniles, so there's plenty of chances to pick up some hitchhikers.
The other thing that we find is that the benthopelagic fishes have a much smaller parasite burden, partly because there's not a surface. When you're a demersal, you've got a surface where everything falls down to, sort of thing. And whereas if you're in the pelagic regions, particularly in the deeper waters, there seems to be a much poorer parasite burden there.
I suppose it could only really be trophic transfer. Yeah. You're not likely to bump into another one. It tends to be something eating something else.
Yeah, that's exactly the case, yeah.
Do they have to become less specialised?
Yeah, I think that's true. The few that have been picked up in bathypelagic fishes are, as far as we know, very generalised, very non-specific parasites, whereas the ones in the benthic fishes are often pretty host-specific. There does seem to be some quite close relationship with the bottom or the slope or whatever. The further away you get away from that, the smaller number of parasites you pick up, until you get into the epipelagic areas where there's a lot of photic stuff going on, and then you do pick up parasites there. There's a sort of big zone in the middle of the ocean where there doesn't seem to be a lot of parasite transmission going on.
Everything's a bit too spread out.
Exactly. Sometimes I think it's a miracle that these things survive at all. But I suppose there's enormous numbers down there, and we're very much scratching the surface of what's going on.
There's a lot of scavengers. Do you think scavenging is a good vector?
Yeah, I think probably scavenging is how most of these things are picked up, yeah.
And the grenadiers, at least, are incredibly long-lived. You can get 40 to 80 years in an adult, so that's a long time to build up a parasite load.
Well, that's it. I mean, the parasite loads are quite good in grenadiers, but as you say, they're probably being affected for 40, 50 years. I mean, another thing is we're not at all certain how long the parasites actually live, but certainly some of them seem to go to quite a big size for a parasite. I think it's not a straightforward life cycle down there, and I think it is to do with the fact that they are so very long-lived, a lot of these things, that they manage to sustain the parasite life cycle down there.
The complexity of the life cycle, the sort of multi-host, multi-stage, is probably a bit of a blessing to these long-lived fish, because they've got such a tight energy budget. They're living on so little food that if they could reproduce within the final host, it would make sense that you could easily overwhelm and kill something like a grenadier on its 40-year life cycle, whereas they live a bit more in balance at this stage when they're sort of ingesting the final stage.
Yeah, none of these things actually reproduce in the final host like that, so they all have to be taken by food. And so that, yes, you're right. It's a balance. Obviously, if they started producing so many, they killed off the host. It wouldn't be an efficient way of running a parasite life cycle.
Yeah, they're playing the long game.
Sometimes at the intermediate stage, I mean, there's cases, for instance, some parasites get into chaetognaths and arrowworms, and they change the colour of the worm, so they become more prominent, and the small fish go for them more readily than the other.
Huh.
Sometimes at the intermediate host stage, the parasite wants the death of the host.
It wants to be eaten at that stage.
Yeah, yes, that's right.
Yeah, manipulating the host is quite creepy.
Yeah, there's quite a lot of really frightening things like that. Even in man, some of these parasites can actually change behaviour to some extent. It's a common thing that the intermediate stages try and get their host eaten, try and make it more prominent or less mobile or something like that, so it's consumed more easily.
Frightening stuff. What would you say is the most grisly among the deep sea? Is there a particularly gross parasite?
Well, I'm not certain it's very easy to say because we're looking at the final host. A lot of these things are in a pretty good balance with the host. There's no point in killing the final host. There are some anecdotal stories about these parasites causing some problem. They're probably grazing on the surface of the gut, and most of them, but making very little evidence of the fact that they're actually causing anything but perhaps very low levels of pathogenicity. So they're not really very grisly in that regard, not like some of the other things that you hear about, particularly the way that parasites change the behaviour of their hosts and do horrible things.
Much more of a balance with the deep sea. It's about not killing the host too quickly.
Yeah, I think so. I think presumably, as you're saying, the grenadiers are so on the edge of getting enough food and actually surviving, so that any major parasite effect would polish them off pretty quick. So I think they're mostly...
Yeah.
It's a good strategy, really, for a parasite not to kill its host, unless it helps it continuance of the life cycle, which it doesn't for the adult parasite, because it's producing a large number of eggs at that stage, and they're just passing out with the feces. And the longer that happens, the more parasites you're going to get.
Well, that makes sense. There's been some theories about congregations of deep-sea animals being a good vector, so things like a whale fall or a carcass that's going to gather a lot of these grenadiers in one place, and I guess if they're gorging themselves, they're probably pooping as well, so they're shedding eggs onto the area while others are there, and I'm guessing for these ectoparasites, the ones actually on the bodies, that feeding frenzy where you see the fish sort of brushing up against each other, that's how they're transferred.
Yes, yeah, I should think so. But I don't think anything's been done on the parasite aspects of that. And again, that would be a very interesting thing to do. I remember that at one stage, Monty was sending down dead dolphins,
yes,
so they could photograph what was happening and following the arrival of things like all these big amphipods that turn up and that sort of thing. I mean, as you say, there's amphipods there. There'll be a lot of other small invertebrates around. So that would be a good place to get your life cycle going.
Yeah. I've got a running theory that we're going to find a whale parasite that completes its life cycle in a deep sea scavenger.
Yes.
It's where they all end up, really.
Yeah, that's right. That would be a very interesting thing to go into that in more detail, because there's a complete community, isn't there, that develops around these whale falls. And
yeah, it's a habitat.
Presumably it's a very good place for parasite transmission to go on. But again, that's just saying that's the likelihood of what happens. We don't know.
Lots of work still to be done.
But I mean, that's the sort of thing that people could do. I mean, it's a really interesting thing to look into that. And then you get down there now with your submersibles and whatnot and do some proper collecting.
Yeah, do some careful collecting rather than trawling.
Virtually everything that I've collected have been done from deep sea trawling, which is laborious. And the other problem is because you're doing a lot of damage at the bottom as well.
Yeah.
Which is not a good thing to do. And there hasn't really been any alternative. But now with things like some of the submersibles and things that can get down there and actually collect things individually, would be a very useful way of dealing with that. We did do a little bit on hydrothermal vent parasites in the Southeast Pacific. That was collected by fish trap, and that's something that could be used.
Yeah, you don't get many specimens, but they tend to be in really good condition.
That's right.
And a lot of stuff gets damaged in a trawl. So if you're after ectoparasites, I'm guessing a trap is great. Is there any misconceptions? Because we like to push against any sort of tropes and things around the deep sea. Unfortunately, the deep sea seems particularly vulnerable to just the propagation of things that aren't true. Is there anything you'd like to set the record straight when it comes to parasites. I think one of the things that surprised me the most here is, it is parasitism. It is a one-sided relationship, but it's much more in harmony than I anticipated. Our perception is something infects your body and it's trying to kill you, whereas actually it's just trying to survive.
Well, yes, a lot of parasitism doesn't seem to have much pathogenicity anyway, and you've got to be in balance to survive as a parasite. So from the parasite's point of view, it's definitely, in lots of cases, it's against your good to kill off the host. So you try and keep it alive as long as possible, and by doing that, you have very little pathogenic effect. Of course, you have some effect because you're taking nutrients away from the host. But usually they are small relative to the host size anyway, so they're having pretty small effect on the actual host survival. So, yeah, no, you're right. Parasites are a problem. I mean, when you get in certain conditions where there's a large number of parasites in hosts, like in a fish farm or in human society where you get a lot of transmission of parasites or viruses, things like that, you can get a lot of problems. But in a normal wild situation, a lot of the parasites have very little effect on the final host, at least. Yeah, certainly the idea of a parasite is that it's sort of trying to gnaw away at your insides and do away with you. Is usually not the case. But then, of course, it depends on what parasite and what their life cycle is like and how they survive. I mean, something like a lamprey or other, you do really damage your host. You bore into it and eat the host and then move on to another one. But with most parasites, it's not so easy to move as an adult from host to host. So you have to keep your host alive as long as possible.
Yeah, it's interesting where the examples of where that breaks down. It's artificial, it's fish farms, it's denser populations than would be natural, and that the parasite has evolved to live in this balance with its host. But if we mess with the equation, then that's when it becomes sort of harmful. I know talking from fishy areas of things, you talk about parasite load, and it's just a constant balance in a fish, and maybe a sickly one, it might push them over the edge because it is a drain on the fish's system. But it's perfectly normal to be, living in balance with these parasites.
Well, yes, parasitism is a very normal arrangement, and quite often it's a indicator of a good, well-balanced ecosystem if there's a good parasite fauna in there. Some of these free-living parts of the life cycle, like the Cercaria, which come out of the snail and find the second intermediate host, these are in the environment, and if the environment's polluted, you're going to lose those parasites.
That's really interesting. That's a good take-home, that parasites are an indicator of a good, stable, and healthy ecology. It's really interesting.
Well, I mean, they are a result of the meeting of individual organisms and the good feeding habits, good feeding conditions. So, yeah, it's certainly an indicator of that.
And that they need so many hosts. They'd be the first to reveal if something had happened to one of the steps along that chain, rather than us just maybe focusing on apex predators and things at the top. If there's a breakdown at the lower trophic levels, maybe parasite load is the giveaway.
Yeah, that's right. I mean, these sort of things have been used as indicators of pollution and of indicators of movements. I mean, some of the life cycle, I'm talking about shallow water stuff that we know more about, some of the life cycles we know, the intermediate host doesn't occur in a certain area, so that we know if the parasite is in that certain area, that host has come from somewhere else. It's a rough indicator of movement and stock conditions. So it has been used fairly successfully as an indicator in shallow water conditions. There'll be one or two cases where they've tried to do it with deeper water, but we often don't know enough about the life cycles to make very strong inferences from that.
Yeah, we don't have the data, but it would make sense with using the larger hosts as a way of getting around. If you're a deep sea pelagic parasite, then you've got the diurnal migration when everything's sort of coming up and down during the daily cycle. And then we don't know what the macrurids are doing. Like, it's such a mystery how they reproduce, but it makes sense that they all get together at some point.
Yes, there must be somewhere. When you're working on parasites, you get used to thinking of parasites as fascinating organisms who deserve to live, sort of thing. Whereas then generally people probably think of them as problems and something to get rid of, which they are in some cases. But in lots of cases, they're just part of the natural system.
Is there any competition on the host? Are there any parasites that actively fight over their host?
Well, there are, yes. I mean, there's some fascinating stuff done in the mollusk where there's parthenogenetic reproduction. In some mollusks where there's 2 or 3 parasites in the same mollusk, different species of parasite, there is predation of one parasite on another.
Wow.
There are groups of these individual organisms that are developed by parthenogenesis who are like soldier ants, the soldier parthenidae that actually consume the other species.
Wow.
I mean, that's snails and things in shallow areas where they really study them in detail. But there's a sort of eusociality in some of these individual species at that level in the first intermediate host.
Yeah, that's pushing the definition a little bit. That could be seen as advantageous.
Well, yes, it could be, but often it just means that one parasite is more dominant in that host, and often the mollusk hosts are in fact castrated by their parasites, so that can be a problem.
Yeah,
there's all sorts of complications like that. Of course, if you've got a group of parasites in a gut of a host, for instance, they'll be segregated.
Really? They pick an end?
Some, front end, and some in the rectum, And also, it's been found that if you've got two parasites in a host, they'll segregate a bit. If you've got several parasites, they'll segregate it more tightly.
Right.
So it depends on what groups of parasites you've got in the host, where the parasite is in the host. Because if there's a lot of different species of parasite, they'll segregate into smaller areas than if there are fewer parasites in the host.
And it's not specialization within that parasite. They will, say one that's usually found at one point in the gut will move over a little bit to stop competition.
Well, there are parasites that have their niches along the gut, but their niches can be bigger if there's less competition going on. And then if there's competition, then the niches will be restricted more. So, if they're on their own, they're not going to be right through the gut, for instance. They'll have a niche, but they'll be quite a wide niche probably, and much smaller if there's competition going on.
That's really interesting.
It's not to do with the deep sea specifically, but presumably this is going on down there.
It would make sense. So there's, sort of looking at this internal environment as a habitat in itself. Are there predators on the parasites, and do the parasites have their own parasites? Are we Russian nesting dolls?
Well, they do have their own parasites. Not much known about that, as far as I know. But you do get other parasites, usually protists or apicomplexans and things like that in the Digeneans, certainly. And also, actually, I remember once we discovered a lump there's a thing called otodistum, which lives in the body cavity of sharks. It's a Digenian, grows to quite a big size. And there were big lumps on it. We sent it to an expert in the States somewhere, and he looked at it and said it was a neuroma, a cancer. So as far as we know, that's the only cancer we've seen in the Digenian.
No one is spared.
No. The sharks are supposed not to have cancer, aren't they? Immune from cancer, so their parasites are.
Yeah, that's what I was going to say, because originally, it's quite often a less scientific cure for cancer is eating shark cartilage. So evidently it doesn't work on their parasites.
No, apparently not.
Oh, that's fascinating. I like that one. How about predation? Are there any parasites that eat other parasites within the host?
Well, only the ones I was talking about in the snails earlier. But you do find occasionally parasites with lumps out of them as if somebody's chewed on them. But whether that's, just a bit of cannibalism or whether it's actually a competition between different things, I don't know. In fact, there's one group, it's not deep sea, but we find it a lot in reef fishes that virtually all the parasites are nibbled away. And I don't think there's not much actual predation of the parasite.
Yeah. You're already in a meat habitat, essentially, so you don't need to go hunting around for other flukes. You're already surrounded by food.
Yeah, again, it's something that virtually everything I've said in the last few minutes has been stuff from shallow water that we can easily study. One presumes that similar things are going on in the deep sea.
Yeah, we have to until we know more, but it makes sense. It's good to base on. That's fantastic. Were there any final thoughts? Was there anything you think I've sort of failed to reach? Anything interesting?
We did do a little bit of work on the phylogeny of these Digenians. There does appear to be, as far as phylogeny is concerned, a bit of actual radiation in the deep sea. So I think there's some evolution going on in the deep sea. But every group that we know in the deep sea has got shallow water relations, although some of them don't seem that close. So there's some sort of radiation going on down there. But, there's one occasion a fish called Epigonus, which is a perciform fish. Don't find many of those in the deep sea. And it so happens that their parasites in the deep sea are related to shallow water parasites. So they've probably gone into the deep sea, I guess, fairly recently, taking their shallow water parasites with them. So there's a lot to be learned about how the deep sea fauna develops. because there are these sort of anoxic episodes, so presumably things are having to be replenished every so often.
Oh, that's interesting. With the deep sea fish often representing some of the older groups, is that reflected in their parasites? Do you see the sort of older lineages present in the deep sea?
No, I don't think we could say that.
Oh, yeah.
A lot of host switching goes on in parasitology, although individual hosts and individual species and genera often have some sort of specificity. Across a larger group, there's an awful lot of host switching, and I don't think that I would say that necessarily the parasites that we find are that primitive. They are embedded within the large phylogeny of shallow water ones as well. Although there are, as I say, radiations in the deep sea. They're not enormous radiations. They're not big, high-level taxa.
Right. So kind of genus level, there isn't a new family.
Yeah, that's right. They're not higher level taxa. And one other thing we did find that was quite interesting, moving away from digenians, in the holocephalans, in the rabbit fishes, there is a thing called gyrocotyle, which you find almost in every specimen.
That's fascinating.
And these are related to the tapeworms. They don't have segments. They are just in one part. They don't have segments like most tapeworms, but they're related and sort of primitive tapeworms. And these are found in virtually every holocephalan you pick out and you look at. But we found in the thing called rhinochimera, which is a very strange looking thing. Have you seen one?
Yeah, they're amazing. I've got one in the collection.
These have ordinary strobulate segmented tapeworms in them. And we found that for the first time. And these are just embedded in the general shallow water shark and shark tapeworm groups. So this is presumably a much later piece of host switching into the chimeras.
Oh.
Only to occur in that one group, in rhinochimera. It's been found, we found it in the North Atlantic and somebody's found it in the Pacific, but never in any of the other chimeras.
Interesting, because the chimera is a pretty ancient group.
One of the pictures I sent you was a picture of a gyrocotyle from Harriota. Have you ever seen that?
No, I haven't.
That's another chimera with a strange nose. That's something that we found. That's a new species we described.
That's amazing.
These are another bit of a branch away from what I've been doing mostly, but we've been doing a little bit of work on these groups.
The chimeras seem to have a particularly hard time because they almost always have the copepods in at least one eye. And then there's at the base of the fins and even the claspers as well. They always seem to have these. I don't know enough about them, but they've got like a holdfast and then these two large reproductive bodies you see sort of fruiting off, but they're quite large.
Yeah, these are copepod parasites. I mean, as I say, virtually everyone you look at will have two of these big gyrocotyle in the spiral intestine, or in the stomach, actually.
And just two? Do they tend to be pairs?
Normally two, yes.
Yeah, that's interesting. The guts are weird in chimera, aren't they? They don't really have a stomach. They go sort of directly into the intestine.
I seem to remember there was a little sort of area in front of the intestine, but I can't remember now. It's a long time since I looked in a chimera.
I quite like the sentence, it's been a long time since I looked in a chimera. I think we're always on the lookout for new T-shirts, so that might be our next merchandise. Oh, that's fantastic, Rod. Was there any sort of final thoughts?
Well, I said really at the beginning, it's a fascinating area, needs a tremendous lot more work, and I would recommend anybody who's got that sort of urge in them to look at parasites. They're a fascinating group, and there's an enormous amount to be done on them.
Brilliant. Yeah, so anyone listening, picking their direction in life, this is certainly a viable one. Lots left to do. What I really enjoy about it is I like ecology. I like sort of interaction and the intelligent ways that things slot together. And this feels like it has lots of that.
Yeah, that's right. Yeah. Well, you're dealing with very close associations between different organisms. And it's something that's really fascinating to try and unravel.
Oh, that's amazing. Thanks so much for your time, Rod. I really enjoyed that. So this episode's quite fortuitous, really. Us, along with everyone else in the world, is pretty obsessed with the Last of Us TV show. I know we had a little chat about it. You're a couple of episodes ahead of me as well, so no spoilers.
Yeah, no, it's good. I like it. But it's nice. I mean, I guess the story's set around the whole fungal parasitology type of thing and the zombie nature of the whole thing. But it's a cool TV show, regardless of that. That's just the sort of
the setting,
and the antagonist to actually a very interesting story. I don't normally like big TV shows like that. I don't really have time for it, but that one is actually particularly good. Love it.
It's got more sort of interesting biology on that. I sort of fell off The Walking Dead because in the first series they were like talking about the infection and they went to the CDC and there was like, I like the science of it and I like it if it sort of makes scientific sense. And then it sort of just became much more people-y. But I like that this one jumps 20 years. So there's no remnants of society or anything like that, that this is the norm now and everyone has sort of adapted to this. And there's a new generation that has never known a world without this. And I'll put a link to it because the opening, which sets the scene, and it's an interview panel from like the 70s and everyone's smoking, and it's a real departure from the rest of the show. But it is really haunting. It sort of sets the scene about how terrifying these fungal infections can be.
It's John Hannah, isn't it? He's talking about fungal parasites can change your behaviour and stuff like that. And he's like, no, that's what we should be worried about. And the guy's like, yeah, whatever, mate.
Yeah, and then they're like, oh, but they can't live in a warmer environment. And then they're like, well, if something forced evolution, like maybe the planet got a little bit warmer. And then everyone watching is like, oh, I know what this show's about.
Before you know it, everyone has an isopod in their mouth.
Oh, yeah. And they stick them out so they can talk to each other.
Yeah.
Gross. Of course, we've got parasitology merch. There was one bit that rubbed up against me a little bit with the show, and maybe they're going to explain this like a bit later on. In the game, the infection is transferred by fungal spores, which makes more sense. I know it's probably more difficult to write into a plot because there's always that like, well, did they breathe in enough? And, you've got people acting in gas masks, it probably doesn't work. So they made it much more simple of like a very direct infection. But the infected are still covered in sort of mushrooms and growths, which are the fruiting bodies, which are to release spores. So I don't know if they're going to address that, but that I like a biologically accurate monster, and that sort of rubbed me the wrong way.
But what's the whole point of the thing of being bitten? Does that mean then only your saliva carries the infection? It's the same in zombie. Why do you have to be actually bitten and draw blood?
Yeah, they went a little extra way with the Walking Dead, where everyone was already infected. Everyone will come back, but a zombie bite is fatal. Like it had a secondary mode to it.
Ooh.
I suppose I've got to explain away why regular dead people come back, not just people who are bitten.
Anyway, we should talk about deep sea parasitology as well.
We could. We're not super knowledgeable, but we've certainly seen a fair bit of it.
Well, that's the problem is we see it quite a lot, we just don't know. I mean, the classic one is the copepod hanging off chimera's eyes. You get these big, huge chimeras swooping around, and they've always got this long, horrible little copepod stuck in. It's normally one per eye, isn't it? Just trailing behind. Yeah. And I've certainly seen some external parasites on the grenadiers down in Antarctica. I always thought Antarctica would be nice and clean for some reason, but it was probably more parasites down there than I've seen anywhere else. And recently, actually, we'll tell the story. This is when a good 10 years ago, I think, we had a mystery fluff. We had the
mystery fluff.
A conference in Glasgow, and we managed to get most of the big deep sea guys, some old guard, some new guard. We got them all in Glasgow to talk about deep sea fishes. And at the end, I asked everyone to start the conference to give me all your weird stuff. And at the end, we'll just have like an hour or so of just showing all the weird stuff that they can never publish, just out of curiosity. And one of the things that emerged from that is certainly us in around New Zealand and around the UK. We're seeing this, what it looked like a fungal infection. It's not fungi because it's in deep sea, but it looked like that on the grenadiers. And as we showed it, I think Vincent from New Zealand said, oh, I've seen it in this place, whatever. And Jeff Drazen off Hawaii and California was like, oh, I've seen it over there as well. And we're desperately trying to figure out what it was. And it turned out Jeff had a sample, or we got someone in to have a look at it, and then they just let us down. We never really figured out what it was. But more recently in Japan, we saw it on this snailfish, and it looks like an encrusted mat of grey matter around the gill cavity sometimes. Sometimes it spreads around the eye. It looks really awful. It looks really itchy. It's obviously not benefiting the animal in any way, but yeah, it does look very much like a fungal infection, but it can't be. So what that is a bit of a mystery.
If anyone is a keen fish keeper, when you have a bacterial ulcer and it gets that secondary fungal infection, it looks just like that. We'll put some pictures in the show notes. But yeah, it looks just like that. If I'd seen it on like a koi carp or something, that's absolutely what I would have called it. But yeah, it's knocking around in some deep sea critters. I think that anyone sort of setting up a conference or even just a meeting, I think that was such a good idea because especially in the deep sea, we'd all had, oh, that was a weird thing, but it's just one data point and you can't do anything about it. Whenever you get a load of people together, ask them to bring all of those up because so many of these, like, I think a few like things came of that.
Yeah. Yeah.
Get someone to sort of like, I saw this weird thing, and then a hand will go up, I saw it too, and I saw it here, and then another hand will go up, and suddenly you've got a data set when you'd given up and thought, oh, I don't know what to do with this one observation.
My favourite one from that session was Malcolm Clark because he had that drop camera of somewhere off New Zealand, Chatham Rise, I think it was. And it has nothing to do with fish at all. But the camera just nudges the seafloor, and it's on a relatively gradual slope, and it starts a little avalanche. And you can see the whole thing of it. You go, oh, yeah, it's kicked up a bit of mud. And then you realise that mud is moving, and it's still moving, and it's still moving, and it goes on and on, and it's travelling the same direction as they're moving with the camera, so it follows it. And it doesn't look steep at all. Yeah, the whole slope just collapsed, just one little nudge. That was very cool.
Like one of those penny games at the arcade.
Yeah.
You drop the 2 P's in and just one of them nudges another one, nudges another one.
Yeah, it's like if you take a Norwegian to Hawaii and start rolling him down a hill.
Yeah.
Like that.
Yeah. Then he bumps into some tourists and they start rolling.
He bumps into a guy from Sweden who falls over, and before you know it, the fins are all over the place.
Oh.
I don't know what's happening here. I don't know why we're throwing Scandinavians down a Hawaiian volcano, but it's better than drowning in Hawaii in a fjord.
Good analogy. So some really nice bits from the interview, including maybe a potential niche bit of new merch, which was Rod just offhandedly saying, it's been some time since I looked inside a chimera. So I'll be up for that on a t-shirt.
I wonder how many people actually truly have looked inside a chimera. To be honest, I have, but I haven't looked inside it, but I have seen its insides on the outside, because when you bring them up, they often prolapse out their anus.
Yeah.
So yeah, that's supposed to be on the inside, but I can see it. Kind of situation. Isn't that supposed to be on the inside conversation? Yeah. Yes, but chimeras unfortunately do that when you bring them up.
Which is interesting because there's no gas in there. I don't know actually what causes the inversion.
I don't know. How long do you want to sit around thinking about that?
Well, it's ruined my week.
Yeah, it's quite gross actually.
Yeah, it's terrible the things we do to these poor beasts. I thought it was interesting the multi-stage life cycles and how actually that, like, it seemed needlessly complicated. It seems like, well, why wouldn't you just sort of exist in one host? That seems to work in balance really nicely. It also seems far worse to be an intermediate host. The final host, the parasites don't seem to want to kill you, but the intermediate host, it's all about hijacking it and reproducing as much as you can and then getting it killed. It was amazing that species compete, so you can actually have almost beneficial parasites because they're killing off the other parasites, but then it sounds like they do hijack your appearance and behavior to try and get you eaten by the final one.
So the intermediate stage is just parasites are just using you for your body cavities.
Pretty much, so that they're reproductive at two stages in their life. There's like a sort of swarming stage within the second host, where you just want to make as much as possible and sort of use the host up, basically. It's a short-term thing. And then when you get into the final host, that's sexual reproduction, and that's when you're sort of releasing eggs and gametes, and that's much more long-term, and that's the host you don't want to kill because you want to live in there basically for the whole of your life, reproducing as much as you like, and sharing the space. That was interesting. Like uncomfortable flatmates, they will call dibs on a certain area of the organism. So species that would say usually be all through the gut, if there are other parasites present, will sort of agree on certain areas and sort of stay to their area. So yeah, this poor fish ends up like a bit of a flat share, and everyone's arguing over who's drunk all the milk, but you have your own areas to stop conflict, and that's much more long term. And I think that certainly with the pace of life of, say, the deep sea fish, because the grenadiers came up a lot, they're incredibly tight energy budget. You know, they spend 40 years saving up enough energy just to reproduce once. Then if the parasites could reproduce within them, that you could easily just overwhelm the host and kill it. So the fact that they have to come through this secondary host means that the fish is always taking in new parasites, but also the old ones are kind of dying off as well, and it maintains a balance, basically, rather than being sort of fatal.
So the parasites don't live the entire lifespan of the host then? They just come and go?
Yeah, they sort of live out their lives and then are sort of continually replenished, basically.
Some life in it.
I know. And when you factor in like the fish migrations and things like that, it's a good way of getting around. They've got really complex life cycles, and then they are a little bit less specific in the deep sea just because things are so spread out. But these like trophic ones, these ones that are ingested, have these quite complex life cycles. And then the ectoparasites, the ones that live on the outside, they basically need contact. So they need to bump into another animal. So you know those copepods we see on the chimera eyes, those two like lobes off those are the sort of reproductive organs. And so you need to get pretty close contact with another chimera, basically. And he was talking about food falls. Food falls are a great way of sort of parasites transferring, because these animals are usually quite spread out, but then a whale carcass comes down, or a big dead thing, basically, just like our camera landers. All the fish gather together, and we've seen how they sort of shoulder up to each other and rub against each other. So that's probably a great way of the parasites getting spread around at the feeding frenzy.
At the discotheque.
At the discotheque. And there's probably something happening on the reproductive end as well, but we don't quite know what grenadiers do.
No one's ever asked.
Oh, it seems rude. They only get to do it once, probably, so it'd be rude to interrupt them.
How do they know, though? Because apparently, weren't you saying a few episodes ago that they probably don't have much of a memory?
Instinct, I guess.
Maybe they're doing it every day, they just can't remember.
I think that's worked out from the energy budget. They probably don't have the energy stored to reproduce more than once.
Didn't you do a cruise in the Mid-Atlantic Ridge when you're pulling up all these big dogfish and stuff like that? And didn't they all have like parasites in their nostrils?
Oh, yeah.
I seem to remember somebody showed me a video of like a parasite being like corkscrewed out of the thing's nostrils.
Oh, it is horrible.
Thinking, that's harsh. It's not as harsh as the I'm your tongue now parasite, but
that will always be the winner.
I'm your nostrils now is pretty grim as well.
Yeah, it was interesting. Like Rod is obviously fascinated by parasitism, and like it's for ecology. You don't get animals living together as closely as that. So it's actually like as a scientific area of study, it's fascinating. But I think totally sensibly, we have a natural aversion to parasites.
So why are parasites never really mentioned when you do a study of biodiversity and the number of species in a given area? Has parasites ever come into that? Because surely the fact that we sort of don't like them and are a bit yucky by them, but it's still an organism in a given area.
Well, from chatting, it seems actually they're brilliant indicator species because they sort of manifest a whole chain of other organisms. If the intermediate organism, which is quite often like a mollusk, if that has been wiped out, then you're going to see that in the parasite population in the fish, whereas the fish might be easier to sample. So actually, they're a high parasite load is a great indicator of a healthy ecosystem, which I found really interesting. And the reason we aren't really looking at this is we don't have that many parasitologists, and they require sort of quite specific sampling. So I think unless you have a parasitologist on board, or as we all go out there and we do sampling, maybe get in touch with your local friendly parasitologist and see how they want things preserved, because they have a tendency to degrade really quickly, and if you preserve them wrong, they just turn into mush. So we're dropping the ball on that. There's loads to be learned from parasites, but we're just not studying them.
Feels like parasites are like second-class citizens. They don't get a look in, whereas they're still just ones and zeros in Excel.
Yeah, you can still draw a lovely graph.
Yeah.
Well, that was Rod's sort of closing remark, was a little bit of a call to arms. Like, this is a really interesting area to study. There is still loads to be done. So like you could take your research in loads of different directions, and there's not enough people studying it. So anyone sort of in their early career and thinking which direction to go in and has been inspired by this, there is green and verdant fields of scientific research ahead of you. I don't know how it works with funding.
Don't let The Last of Us put you off. It'll be fine.
They might be having a great time in there.
If you had to have a parasite, where would you want it?
Oh, no.
Yeah, I would like a pair of ectoparasites. I would have them on my ears as a nice pair of earrings.
Oh, that's not too bad.
Yeah.
In Dark Souls, you can get an egg laid on your head, which then hatches into a big grub. So you end up walking around the rest of the game with this huge tendril sticking out of your head, and you can use it as an attack.
You're talking about computer games again.
I am. But Last of Us was a computer game first, so it's cool now.
But we were talking last week about someone's going to watch us play computer games.
Yes, yeah. I've been looking into sort of ways of making that happen in potential games. I'm looking for something maybe a bit more decision-based-y rather than reflexy, because I think, like, if it's something where you have to make decisions, like us both doing it...
Like FIFA 96?
Yeah, we'll play Football Manager. If anyone has any recommendations, let me know. I bought Soma in the sale thinking that might be an interesting one. That's a deep sea one. But I was talking to Prema and she said it deals more with sort of the nature of consciousness and things like that. It gets quite philosophical. But I think there is some deep sea scenes in that.
Well, I thought, what's happened to computer games? I thought it was like two big dudes punching each other in the head. And you just keep going until you've punched the person in the head so much that you win. Isn't that?
But now the person you're punching in the head has this like elaborate, rich backstory, and you're crying while you do it.
Oh, no. This is one of these games that takes like 8 years to complete.
Yeah, and you have to be sobbing at the end of it. It has to be like an emotional experience.
So I can't just give you a special move, which is like a double tap on the elbow on the smackdown, and then declare the winner.
You've got to be lost in another world.
Oh, lots changed.
It has.
Either way, I'll still beat you anyway, so... Bring it on, that's what I say.
It should be something decision-based that we do by committee. We sort of discuss what we decide and see what happens in the story.
I don't care, just pick a game and let's do it. I still don't understand why people want to watch us do that, but okay, fine. I'm not competitive or nothing, but I will win.
Even if we're meant to be cooperating, you will win?
Yeah.
Right.
Well, even if we're on the same side, I'll still be better than you. That's what I'm saying.
Oh, okay, good. I'm looking at my my symbiosis graph here and seeing where that falls, where our relationship falls.
Yeah, we're both. It's an advantage to both of us, but one of them is better.
Oh, okay, right.
What's that called? Is that competitive competition? Positive competition? Encouragement? Influencer? A parasitic influencer?
Okay, you're an influencer. I'm going to add that to the. I can change the wiki today.
Yeah.
We've got wiki editor rights, so yeah, we'll. I'll add that to the chart.
Yeah, sorry.
Hello, my name is Don Walsh. I'm an oceanographer and explorer. but also in a former life, I was a submarine captain. So I'd like to talk about a little sea story that I have called Submarines and Parasites. Back in the late 1960s, when I had command of the submarine, I used to volunteer for research and development projects that were being done by the underwater research laboratories in the San Diego area where my submarine was based. One of these projects was to help test out a portable underwater listening array being developed by the Navy. And in the experimental stages of development, and they needed to test the array against target submarine. That was us. Now, this portable array was designed to be temporarily installed on the seafloor in areas where the Navy might expect submarines to pass through narrow areas, such as, say, the entrance to a harbor or a strait between two islands, something like that. So we went up to the area just off Los Angeles Harbor and started to make racetrack runs for the array. And we were asked to operate in different modes. For example, on a battery only, for a super quiet mode, or running one or more of our engines while submerged, because my submarine was equipped with a snorkel system, which was a way that we could run engines submerged by use of a intake pipe sticking up through the surface and an exhaust pipe also sticking up above the surface. And we were in an area of pretty heavy traffic because, it was the entrance to the Los Angeles Harbor, and we had to be kind of cautious. So I spent that whole time up in the conning tower with the watchstander officer next to the periscopes there so we could see what was going on. And we were averaging, our depths were somewhere between 48, 52, 55 feet, depending on what part of the test card we were doing, what mode we were operating in. The idea, of course, was to give the scientists developing this array an idea of what a real submarine might sound like in its various stages of operation, from super quiet to kind of noisy. But we never were on the surface. So here we are going around this racetrack, doing the various things that we're asked to do, various modes of operation. And I was next to the sonar man who's listening for traffic, because there's certainly a lot of traffic around going in and out of that major seaport. And we had to be very careful because most of them couldn't see a submarine. Even though we only had these two pipes sticking up through the water. And so we were kind of hyper alert. The sound man said, "Captain, I think I hear a small fishing boat," something like that. I mean, I can hear all these tankers and big cargo ships, but this is a high-pitched noise like an outboard motor. I said, "Okay, well, let's have a look." So I got over the periscope and looked outside, and I could see this small fishing boat, probably 10 or 15 feet long, and one guy standing up with a fishing rod doing some sport fishing. Well, that's fine. He's not going to be any threat to us. I mean, if he bumps into us, woe be unto him, because he'd probably get sunk just colliding with one of my pipes that are up in the air. And he noticed us. Well, he should, because that diesel exhaust smoke coming out of the exhaust pipe, even though we were submerged, it's pretty easy to see, and it might have been even a little smoky. So, and if you're downwind from it, it smells like any other diesel engine, like a bus or truck. I could see him. He's turning on his motor, and he sped it up and headed over to us. Well, that's fine. I mean, he was curious. I think I would, in the same situation, I would go over and see what it was that's kind of under his feet. But when he got right up next to me, strange thing happened. He opened up his coat. He had like a ankle-length coat and some kind of ball cap on, and he didn't have anything on underneath. He flashed us. Can you imagine that? I got flashed by a sport fishing boat, and I couldn't believe my eyes. I put the watch officer on, and he confirmed what I thought I saw or what I did see. And so I got in the intercom system on a sub, and I said, "This is the captain speaking, and we've had a lot of traffic here. You can hear them through the hull, these big ships grinding in and out of LA Harbor. But let me tell you about what just happened to us." So I told him about getting flashed by this citizen in his sport boat. And then after a few minutes, he closed his coat and drove away. So in keeping with the spirit of this month's podcast, I thought I'd talk to you about parasites and submarine, because human parasites are almost as deadly sometimes as those that are dealt with in biology or entomology. And that is, they're things that attach to you and you can't get rid of them. And we all know people like that. That's my sea story for this month. Thanks for listening. I'll see you next month.
concludes this episode of the Deep Sea Podcast. As ever, you can get in touch. You can find all our social media links below. There is an email address. Ask us questions, comments, any sort of way you want to engage. We're a friendly bunch and we'll try our best to get back to you. We have a few interesting things in the pipeline. We're spinning a few plates at the moment, but it's exciting. So I think I maybe mentioned it on the last episode, but we're working on a deco stop, which will be a neurodivergency special. So again, deco stop is more about the scientists than the science, if that makes sense. It's more human orientated. So we're going to talk about, being neurodivergent within the field, difficulties offshore, but also advantages as well. There are advantages to thinking differently, especially as part of a team. So that is coming up in March, and we're really excited for that one. It's come together quite well. And we've started a newsletter, so you can sign up to that as well. It'll be in the show notes, or if you go to our website, a little bit of behind the scenes show stuff, a little bit of reminder of what's in there. And if you don't have time, even for the pressurized episode, it has links that will take you sort of directly to that part of the episode. So if you just want a little bit of Don, or you just want to hear from our guest, then you can follow those links and dive right in. But it gives you a little bit of a teaser what's in the episode and what we're up to. So please do sign up if you get the chance. And I think that's about it. So as ever, we'll deep see you next time, and I miss you already. If you would like to advertise with the Deep Sea Podcast, feel free to get in touch. Our audience is primarily young people with an interest in science, often undergraduates or people considering a degree in marine science, but it also includes established scientists. Feel free to get in touch if you're interested in reaching these groups.
Do you think we finally try to pass off a study that we don't actually fully understand, and we've just been caught out by fumbling that something wrong?
No, I think that's...
No?
that's
we nailed it?
No, I got it.
Right.
Yeah.
No,
Swish.
Norwegians, eh?
Norwegians is a descriptive device.
Yeah.